Okay, we're continuing Algebra 6.1. We're on the second day. Still talking about properties of exponents. Just a quick 1-minute review of two properties that we went over already. As long as a is not 0, anything to the 0 power is equal to 1. So that's something that you should know. And then using negative exponents, again, assuming that a is not 0, a to the negative n power is the same as 1 over a to the nth power. Or sometimes you saw that you have a negative exponent in the denominator or on the bottom of a fraction, 1 over a to the negative n. That would turn in a to the nth power. So we have our 0 exponent property and we have our negative exponent properties. And then the next property of exponents that we'll cover is the product of powers property. So I want to go over an example first, something like x to the 6th times x to the 5th. Instead of having to memorize all the properties of exponents, if you come up with a specific example like I just did, you might be able to figure out what the rule or property is without having to memorize it. So I'm multiplying x to the 6th times x to the 5th, assuming that x is not equal to 0. That's what you have to do for every single property. Assume that the base is not 0, or it has to be given that the base is not 0. But let's just say I'm not sure exactly what to do with the exponents. One thing that you should have for sure is the same base. If I didn't have the same base, I wouldn't be able to apply the product of powers property. But let's just say we went over the product of powers property already, and then you can't remember what to do. Here's what you can do in order to figure out what the rule is. I could write everything out in expanded form. Right now, I'm multiplying these exponents together, or these powers together, and what we have is the same base, x to the 6th times x to the 5th. And each of them are written in exponential form. They're written in terms of an exponent. So for x to the 6th, I could write that out in expanded form. X multiplied by itself 6 times. 1, 2, 3, 4, 5. So right here, all of this is still x to the 6th. I'm just rewriting everything to try to be able to figure out what the rule or property is. And then times x to the 5th. So x times x times x times x times x. Right here, this is x to the 5th. If I count up all the x's, x times x times x, there should be 11 total x's. So this would be the same as x to the 11th. And then you can figure out exactly what the rule is. And instead of having to write everything out in expanded form every single time, x to the 5th times x to the 6th, I said it the other way around. It should be x to the 6th times x to the 5th is the same as x to the 6 plus 5. So we can add the exponents there, x to the 11th. It's a little bit quicker and faster to come up with the rule instead of having to write out everything in expanded form right here. But then that leads to the product of powers property. As long as I have the same base, and again, that base is not 0, a to the n power times a to the m power. I have the same base. The rule is, or the property is, add the exponents a to the n plus m. Word for it. The opposite of product of powers property. So product means multiplication. The opposite of multiplication is division. That's quotient. So the opposite of the product of powers property is the quotient of powers property. So I have a specific example. Again, this is a quotient. Quotient means division of powers. So t to the 9th is a power, t to the 4th is a power. Again, I have to assume that the base is not 0, and it has to be true that you have the same base to be able to apply or use the quotient of powers property. But let's try to formulate the quotient of powers property. Here's what we can do with both the numerator and denominator. Both the numerator and denominator are written in exponential form. I could change each into expanded form. So t to the 9th in the numerator, t multiplied by itself 9 times. This is expanded form. If you count them all up, that's t multiplied by itself 9 times. And then you could do a similar thing in the denominator. T to the 4th is the same as t multiplied by itself 4 times. And then what happens here is 4 t's in the numerator cross with 4 t's in the denominator, because this t over this t is 1, and so on. I didn't have to cross off the first 4 in the numerator. I could have crossed off the last 4, but here's what we're left with. In the numerator, t multiplied by itself 5 times t to the 5th, and in the denominator, we have 1. I'm just not going to write it as t to the 5th over 1, although you can. And then the rule for the quotient of powers is as long as you have the same base, you could subtract the exponent. So t to the 9th over t to the 4th is the same as t to the 9 minus 4. 9 minus 4, that's t to the 5th. The opposite of product is quotient. The opposite of adding the exponents is subtracting the exponent. So in general, what would work for any power is if I have a to the m power over a to the n power, same base, as long as a is not 0. And here's what we have to assume as well. We have to assume right now that m is larger than n. It's a little bit different if the variable exponent in the denominator is larger than the numerator. We'll talk about that in a minute. But then you could subtract the exponents. A to the m minus n is what it would equal.